Alright, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good, so last video we did submit a little bit of a refactoring to unassemblize. So, how do we proceed now? Da, da, da. Okay, good, which function? In code section. Okay, so what we do need to do is also work in the unmatched functions on both sides. And I think what we also need to do is break down these functions into smaller chunks. So right now, let's see, bundles. Function bundles. Bundles. Build bundles. Poof. Disassemble. Okay, what is happening here? That's pretty simple. Disassemble. I think we want to build variants of functions. So for example here, disassemble function match. Function matches. So there's this comment here, build matches per requested source file or compiler. But can we really do this? Build matches just for specific compilants? I mean, it sounds... I'm a bit skeptical of building like all the matches all at once, you know. Like the more it becomes, like right now it's not a problem because there are not many matched functions, right? So I do wonder if it becomes a problem later when there are more functions on both sides. I don't know. Let's think about this real good. Let me see. Build function bundles. Function bundle. Well, we don't really have I can't make sense of it if it makes sense to just build some matches. I don't even know how we would get there easily, because so we have functions here, and we would basically need build function matches. But basically, we would have a function list on the side where the PDB is, and then we would find the matching symbols on the other side. But then it makes things complicated, doesn't it? Yeah, and also it makes it very dependent on the PDB. Yeah. Oof. How long does this currently take? Just estimate. Just Put a breakpoint and see how slow or fast it is. Oh, that was very fast. Huh. Okay, maybe I'm worrying too much about the performance impact of these two steps. This one was also pretty fast. What is the longest here? I mean, this is pretty much instantaneous here. This one takes a bit longer. This one also takes a bit of time. Huh. So I wonder what actually takes the longest time then here. It's probably the stuff that comes before, like loading the binary. Yeah. And this stuff is super fast actually. Okay, maybe we don't need to do much here with these things. We just do it all in one go, but I don't know. Yeah, right now the sample size is kind of... Wait, let's see. How about we do... So right now it has 91 matches, right? So for int I equals 0, I smaller, let's do 1000 iterations. So that would be 91,000 matches being populated. Obviously this way it will do more work than it actually should, but just a stress test. Let's see how fast this is. Basically, we just estimate. I mean, we don't put a timer here. We just feel. We just feel it. Yeah. Let's see. Okay, so now 1000 iterations. Oh, that was pretty fast. Huh. Let's see the next step. How fast is this one? Maybe I'm worrying too much about these two steps. Maybe it's just super fast and we don't care much. Let's see. That was less than a second or so. And that was super fast. Yeah. Maybe we don't need to worry about this. And we always do them in one go. So basically, like every time we load a function. So let's say, so the problem I see is that, let's say you develop, right, the tool, you reverse engineer and you make changes in a function and you want to see the difference that it makes, right? And you make a change and you want to see, okay, does it match now our targets, right? And then obviously you need to go to the tool and you need to reload, and that shouldn't take too long, right? It should be relatively fast so that you can see what's going on. Yeah, if it takes too long and it becomes annoying to use. Okay, well, 1000 iterations have been relatively fast. Good. So how about build function matches? Build bundles. Okay, let's rename this to match bundles. Build match bundles. Good. And this is build matched functions. So we will need also a function to build the unmatched functions. Build unmatched functions. So here we will have to pass the matches. Function name to index map. Matches. Function. This name is confusing, isn't it? Similar address to index map. Probably matched functions. And we do matched function name to index map. And then from this we build unmatched unmatched functions and unmatched function name to index map. I think it's not strictly necessary, but we can also make this const. Maybe it's not necessary. Let's remove this comment here. Okay. Unmatched functions. We also need to pass const executable. So executable get symbols. Get symbols. Xe symbols. Symbols. Const. Const max reserve size t is symbols dot size t size minus matched functions. Assert. We expect that this size is bigger or equal this size. If it's not, then that would be weird. Okay, then we do matches, unmatched functions dot reserve max reserve, and this also max reserve, and then do symbols, and we hammer through. We do this in code section index. Can we perhaps reuse this? Static bool in code section, and we pass const executable symbol executable symbol. In code section. So we do code section executable code section, and then this. symbol address. And then we put this here in code section. Executable pair. Less index. More symbol, get symbol. If the name is empty or it's not in code section, continue. Yeah. Matches. I wonder if we should reserve more here, because 512 is it's not much. Maybe reserve 1024 times 4. Or just that. Okay, but we now have this here, executable pair. More index. Okay, how about we make a const executable less exe is that, and more exe is that, and less exe so less exe we can then pass here and more exe here. Can remove this. And here we do max reserve. So we do not in code section. Symbol. executable. Maybe we should swap the arguments. Symbol first. Because we say symbol in executable or in code section. So this in this. I think it's more logical to put the pass symbol first. Doesn't matter much, but I think it just makes it logically a bit better on the eyes. Yeah. Okay, so if not in code section, then we skip. I'm surprised here we don't check for less symbol being empty. Why? Well, if it was empty, then it would return here. Okay, but to me it looks like this check should be here first. Either here or here. How likely is it? Probably not likely. Yeah. Let's put it here. Or less symbol name empty. Right? Okay. Okay. Then we do the same here. And then we don't need that. And then we do index match functions.size and place back. Unmatched. And then match unmatched dot name equals symbol dot name and unmatched dot function dot set address range symbol dot address symbol address plus symbol size. Right. And unmatched function name to index map. Unmatched name equals index. Yeah, so this would be how we build the unmatched functions, because when we have the matched functions, we know, just by that, we know what things will not be matched, right? We have a lookup. We have a lookup, but it puts this dependency. I wonder. Unmatched. Maybe it would be nicer to make it independent from matched functions. So unmatched functions can be built from just executable, because basically we also have lookup here with this get symbol, which is also fast, isn't it? Let's see, symbol name to index, string to index map is also an unordered map. Yeah. So maybe we do it that way instead. Okay, so build unmatched functions. Then the advantage would be that then the unmatched function can be built in parallel of the matched functions. Yeah. So we should make it dependent on this one. Okay, then let's change this. So we have executable unmatched. How do we name this? Let's call this unmatched executable, and then we have another one. We call it other executable. Yeah. Okay, then we remove this stuff here, and we pass these two. Okay, so let's rename this to, we can't. Somehow we can't rename anymore. Huh, we can now. Unmatched symbols. Let's remove this. Then to reserve 1024. Then we have other executable, other symbols. We don't need that. Unmatched symbols. Let's just rename it to symbols. And then we have this here. Other symbol. Other executable. Get symbol. Dot. Oh, I just realized now why this check was here. I don't quite like that this thing returns something when it doesn't find something. I already didn't like it the first time I saw this, but I didn't get around changing it. How about we change it now? Because returning an empty thing when you search for something, that's weird. It's not like that's a real anti-pattern. So basically here it returns an empty symbol, which is bonkers. Okay, how do we do it? Okay. Okay, let's change it to pointer. And this. And this. this. And this. Here we return null pointer. Yeah, don't return empty things unless there's a specific reason for it. Otherwise, just return null pointer. That's fine. If you don't find it, return null. But don't return magic empty things unless there's really a specific use case. Then it's okay. Okay. I think that was simple enough, but we probably get a bunch of compile errors. But it should be straightforward to fix once we hit them. Like here, for example. Other symbol. So we can now say here, other symbol, if other symbol is null pointer, or so now this is much more obvious that we haven't found it. Like, it's much more obvious what this is supposed to mean. In code section, not in code section, other symbol and other executable. There we go. Wait, is that correct? No, it's not. If other symbol okay, let's fix this here as well. More symbol. More symbol. It's not a pointer. Less symbol. Well, we make a P more symbol. And then okay, so if the other symbol is, so if the symbol name is found in the other, so if it's not null pointer, and in code section, then continue. right? Other symbol. Yeah. I think this is correct. Maybe. Okay. Symbol. Symbol. If symbol is not null, okay, how about we make a little bit more systematic? If symbol not null. Okay. Okay. Add pseudo symbol. if symbol is not null, so yeah, symbol is not null pointer, then return false. Okay. Good. Then back to runner. Then how about we test if this actually works now? So just put it here, tests and tests, and we have unmatched functions, unmatch. Let's see. Build unmatched functions, unmatched. Map unmatched executable. So we take 0 and 1, and then we do the same for 1 and 0. Oh, well. Voids. Let's say, okay, true. Okay, let's see if that works. Do we need to step through? Yeah, let's step through. Symbols. Encode section, continue. Let's put a breakpoint here. Other symbol. Okay, continue. Let's put a breakpoint here. Okay. Index and place back. Matched. Okay. Let's see, unmatched 254. Okay, why is our map smaller? Some duplicates, maybe. Okay. Let's see the next one. 0, yeah. Okay, 20,000, yeah. Huh, so this one is matching perfectly. What about this one here? 91, 91. Okay, why is this the first one? Let's confirm this once more. Yeah, so this is unexpected. There are 7, no more, 11 entries. This one has 11 more things than this one. This seems unexpected. How about, let's put a break. Let's here if this dot find unmatched name is not end, then I don't know. Just need to do something. Int I equals 0. Breakpoints. Let's see what that hits on. E8. Okay, we don't really care about E8. No, what else? E9, E4. Okay, this is just things we don't really care about. Oh, that's fair then. Okay. But why are they duplicates then? So it means there are multiple functions with the same name. Strange. Very strange. Well, as long as we don't observe an actual problem with it, I guess we don't care much. Good, I think this works in principle. Yeah. So what this allows us to do then is to see like things missing on either side. Yeah, but we don't use it right now. But in the UI, we probably will need it. Yeah. Good. Yeah. Build match bundles. Matches. Actually, we should probably keep the code for testing for now, because there's a bunch more things coming up for that. Yeah. Good. time is it? 1 hour 24. So I would like to also rename here unmatched functions. Let's call this so matched function name to index map and matched functions. Okay. Oh, something is wrong. It was a rename. Matched functions. Okay, good. And so we can now build matched functions and unmatched functions. Okay, that's great. Now we need to build match bundles. So here, currently, it only builds with this stuff. Okay, so we also need to build match bundles, so it contains this here, unmatched functions. So we need to build that as well then. But it needs to be optional. Needs to be optional. Yeah, actually, I would like to take a break now. Let's continue right here in the next session. Yeah. All right. Yeah, today we just have a bunch of short sessions, but that is fine. Don't have to always do 2 hours, 3 hours, right? Sometimes we do a little bit shorter. All right, then I wish you a great day or night. Until next time. Goodbye.